Hello everyone. I'm Andy from ThinkMo. I am currently teaching CCIE courses. From today on, I'm going to share with you CCNA, CCNP, CCIE related technologies. Our topic today is differences between Layer 3 switches and routers. We mainly based on the following several aspects to explain. The first is its functionality and interface. The second is the corresponding forwarding principle. The third is what features it supports. The fourth is the corresponding application products. Let's start with functionality and interfaces. Let's explain it accordingly. A router is a network device. It is mainly to satisfy different types or some complex network connection between a LAN and a WAN, for example, or between LAN and LAN. Then you have to communicate accordingly. We can draw a picture to show you. Let's say this is Company A's network. This is Company B's network. In order to communicate, you have to rely on the router to make the connection. The router. Company A has to connect to the router first. Company B is connected to the router. Company B then forwards the data. Let's say we want to access the internet. You also need to connect through a router. Take for example, home to do broadband after the internet. Then you can go to the website or download the corresponding materials. It all has to do with routers. The main advantage of routers. It's the ability to choose the best path. Let's say there are multiple lines to access. There are 2 or 3 broadband channels in the house. For the corresponding resource, go to Baidu to visit the telecom line. It's the shortest and fastest. The router can then select the telecom line. Others like connectivity or mobile. It works for some websites. The path has to be shorter. It will give you the best path to take. Then the data is forwarded. If a line is too slow, can 3 lines run data at the same time? Routers can support these functions. Link backup can be realized. Some load sharing accordingly. Load sharing is when several lines run data simultaneously. The corresponding routing information is exchanged. At the same time, some complex networks can be implemented, or connections between different networks. We've already covered that. Besides, the most important function of a router. Yes, broadcast domains can be isolated. What does it mean to isolate a broadcast domain? Let's say this is the corporate network. There are some computers. This is PC1, PC2, PC3, PC4. For the LAN class may lead to attacks. These things are all due to the format of the broadcast. We'll talk about switches in a minute. We can listen to the announcement. Let's say this is switch SW. If these devices are all connected to a switch. For the switch, have the corresponding MAC address table. It's like a map. It's forwarding entry MAC address table. What does a MAC address table mean? For example, PC1 accesses PC2. This is the entry through which it will forward. Let's say PC1 accesses PC2. It relies on a table of MAC addresses. Conduct data forwarding. The MAC address table was covered earlier. First of all, the very beginning. The switch does not have a MAC address table. At this point, the PC will send data to ask. Let's say it wants to access PC2. ARP requests are involved. After the data is sent to the switch. What if the switch doesn't have a MAC address table? It's going to flood. Flooding is all but the first mouth. Because the data is coming from the first mouth. Then all the other interfaces send a copy. So these pieces of equipment. There is no need to receive the broadcast data. Once these computers. Unnecessary data was received. Definitely have to deal with. You need to see if it's looking for you. This is completely unnecessary. We assume that PC1 only accesses PC2. There's no need for 3 and 4 to receive broadcast data. Then we can use the router. Replace the switch with a router. You can isolate the broadcast, because the router itself does that. The router implements these functions. It indicates that there are many types of interfaces. For example, as we mentioned earlier, Ethernet port, POS port, serial port. For a box router, it has fewer fixed ports. Some routers can also be plugged through the interface board, and some boards to expand the number of interfaces. Of course, the box router is not supported. These are the features and interfaces we mentioned. That's for routers. Here's a Huawei router. You can see the router here. Fixed is this many ports. It can't be extended. The same cannot be said for switches. The switch has many ports. Switch ports are divided into 5 ports. 8 bytes, 16 bytes, 24 bytes. This is a 48-port switch. There's obviously a lot more interface than a router. There are just a lot of different routers. The purpose is to achieve different functions. And then there's how it's forwarded. A router is a routing-based engine to perform the exchange of data. The forwarding principle of the router is to query the routing table. What does a routing table mean? Let's say we have some destinations. There are 3 ways to get there. The destination performs the longest mask matching. What is longest mask matching? For example, 10.1.1 has such a route. Sent from the first interface. There's another route that looks like this. Sent from the second interface. And this route. Sent from the third interface. Let's label the mask. That's 8.16.24. So it's going to choose the one with the longest mask. Match them in sequence until we get to this one. The conversion efficiency is slower. It's the same as the switch. There's no comparison. And the switch is through the hardware to perform the exchange. Let's say the switch receives data. I'll just go by the MAC address. Then look for the MAC address table. Carry out data forwarding. We've talked about routing tables in previous videos. That's the difference. We won't go into too much detail here. Then let's talk about the features it supports. For example, routers support multiple types. Protocol at the data link layer, like early PPP, HDLC, FR, or ATM. Routers can better support VPN functions, like IPsec VPN, GRE VPN, L2TP VPN, and so on. And layer 3 switches, except MPLS VPN. Well, technically speaking, it doesn't support some VPN technologies. Link layer protocol supported by layer 3 switches. There are only a handful of them. And then there's the fourth aspect. Its application scenario. Layer 3 switches have many ports. It is suitable for the intranet with frequent data exchange. For example, in the company or the campus network of the school. There's a lot of terminal equipment to connect to. You need the switch to do the access. Routers cost a lot. And if the realization of frequent data exchange, still preferred switch. Routers are suitable for exchanges that are not very frequent, such as LAN and Internet. Of course, LAN to LAN connection. It's actually better to use a switch. So the biggest difference between layer 3 switches and routers. It should be mentioned here. For most switches, especially box type, yes, the NAT function is not supported. NAT is called Network Address Resolution. When we were on the internet, you have to have this function. So when you let things loose in the house, it has to use a router. even the cheaper routers. Switches can't do this. It has to translate network addresses. There are also some switches that are supported, like a box switch in a data center. You can insert a board card. Then the NAT function can be extended. It doesn't directly support things like the S7700. It is supported by extensions. It's better to be native. Late expansion is always somewhat supportive. It's not so good. That's all for today. If there are any other skills you'd like to learn, feel free to leave a message or send me a private message. If you're interested in what I'm talking about, hope to like and subscribe more. Thank you. See you next time.